Okay, so let's do a few practice problems here. We're going to start with a few where we're given the magnitude and the direction of a vector. And what we want to do is we want to draw the vector, if that diagram is not already given, draw the components, and then we're going to find the values of those x and y components. And that's where our trig and SOHCAHTOA is going to come in handy. So why don't we do the first one together, and then if you want to pause the video and try the next two on your own, that is great. So here's my first vector that I just redrawn over here. First thing I'm going to do is draw the components. So we have one component going up, one component going to the right. And I'm just using the angle that I'm given so that 53 degrees that I know is part of the triangle, but you obviously could draw it the other way and find that other angle. Now that I have that, I want to find the two sides, and really it's just a matter of doing some trig here, right, using SOHCAHTOA. So this is the adjacent side of the triangle. This is the hypotenuse, so we know that cosine of theta is equal to adjacent over hypotenuse, so I can say cosine of 53 is equal to y, that vertical component, over the hypotenuse, which is 21. All right, I'm going to go ahead and cross multiply here, and I find that my y component is going to be 21 times cosine of 53. So that gives us a value here of 12.6, and the units would be meters because those were the units of the initial hypotenuse. Okay, moving on to the x side, we can go ahead and find that as well. This is going to be the opposite side of the triangle. All right, and we know our hypotenuse, we also know our adjacent, but I'm going to use sine based off the hypotenuse, which is opposite over the hypotenuse. And so we can say that sine of 53 equals this x side over 21. We cross multiply once again, and we find here that x is going to be equal to 21 sine of 53. And we go ahead and calculate that, and we get that x here is equal to 16.8 meters. Okay. Two important things about this. Number one, I'm okay with you just jumping to this point here, okay? Rather than writing out cosine is adjacent over hypotenuse, cosine of 53 is y over 21, you can just jump to the fact that the adjacent side of your triangle, the adjacent component, will always be the hypotenuse times cosine of the angle, and the opposite component will always be the hypotenuse times sine of that angle. All right, so we can make that jump because we are going to be doing these a lot, all right? The one thing you want to be careful of is cosine will always give you the adjacent side and sine will always give you the opposite side. Do not get in the habit of thinking that sine is always the x side or sine is always the y side. That is going to vary. What sine will always give you is the opposite side, the side that the angle is looking at, and cosine will always give you the adjacent. So why don't you go ahead and try the next two problems, pause the video for a second, and then come back and check your work. All right, so for vector B here, for that second question, we have 8 newtons at an angle of 26 degrees north of east. So that means I'm drawing a vector that's going the northeast direction. And my angle here is measured from this east side, and it's 26 degrees north of it. So there's that angle, 26 degrees north of east. Okay, so I'm first going to draw my two vector components. So I have one going east, one going north like that. And now I'm going to go ahead and solve for that. So for my x component, that is the adjacent side, which means that x is going to be equal to 8 cosine of 26. And my y component is the opposite side, which means it's going to be equal to 8 sine of 26. So I go ahead and calculate these, and I get that my x component here is 7.2, and it's going to be newtons because that was the unit of my hypotenuse, and the y is going to be 3.5, and that's also in newtons. And so you see here, we're just jumping right to these 2 points, and like I said, I'm totally fine with that. If you feel the need to write it out every single time, if that helps you out, that's perfectly okay, but it's certainly not necessary. Moving on to the last one here, we have 15 meters per second at an angle of 25 degrees west of south. So I know that this vector is going in the southwest direction. And when I go ahead and think about my angle, it's west of south. So that means we're starting with south and going 25 degrees west. I can go ahead and draw my vector components from there. I have one south component and one west component. Okay, and this hypotenuse here is 15 meters per second. So I can now solve for those two components. So my x component is going to be the opposite side in this case, opposite that 25-degree angle. So 15 sine of 25, which means that my x component is equal to 6.6 meters per second. Okay, because that was the unit of my hypotenuse. And my y component is the adjacent side. So it's going to be 15 cosine of 25 here, which gives me an answer of 13.5 meters per second. For this next one, we're going to go backwards now. So rather than finding the components based off of the magnitude and direction, we're going to find the magnitude and direction based off of the components. So we're first going to draw our two components, draw them tip to tail to put them back together. All right, and then we're going to draw the overall vector. And from there, we can find the magnitude and direction. So for this first one, we have 6 newtons going left and 8 newtons going up. Notice how I line them up tip to tail, which means that my overall vector is going to be like that at an angle, going from where I drew my initial vector to where that final vector ended up. Okay, and now we want to find the magnitude and the direction. So to get the magnitude here, we're just going to Pythagorize this. A squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared, which means my hypotenuse here is going to be 10 newtons. And now I'm going to go ahead and solve for my angle as well. So to do that, I know 2 of the sides of my triangle. And again, I could use the hypotenuse, but I'm going to use the 2 sides that I know, that 8 and that 6. And those are the adjacent and opposite sides. So what I'm going to say is, thinking about SOHCAHTOA, tangent of theta equals opposite over adjacent. So tangent of that angle there is going to be the opposite side, 8, over the adjacent side, 6. So I now want to solve for my angle. And the way I'm going to do that, right, we can't divide by tangent here. Tangent's not a number, it's a function. The way we're going to do that is by undoing that tangent, by taking the inverse tangent. And there's some information on the next slide about this if you want to get a little bit more in depth here. But the way we undo tangent is we take the inverse tangent. So when I take the inverse tangent of tangent, I'm simply left with theta. And when I take the inverse tangent of 8 over 6, I have tan inverse of 8 over 6, which I can do on my calculator. Okay, I'm just doing second and then tangent. Pulls up that inverse tangent button. And what this does is it undoes that function. Tangent's a function. The way we undo that function and get this theta by itself is by doing inverse tangent. So I end up here with an angle of 53 degrees, and the direction would be, based off of what I have here, I'm starting with the west direction and going north. Okay, so I would say it's 53 degrees north of west. If you drew your vectors the other way, okay, so if you drew it like this and then like that, and you found this angle instead, that's perfectly acceptable. It would just be 37 degrees west of north then. So either one of those answers is acceptable for our direction. So there's our direction there. There is our magnitude. So we would say that this vector is 10 newtons at an angle of 53 degrees north of west, or at an angle of 37 degrees west of north. So go ahead and try the other two, and then come back and check that with the video, and we'll go over them. Moving on to B, we have 10 meters per second east, and then 8 meters per second south, so that's how those vectors would line up. Of course, as always, you can go south first and then east, it doesn't matter, but that gives us our overall angle there, or our overall magnitude, and then our angle. So we're going to go ahead first and Pythagorize this to get the magnitude of this vector. So a squared plus b squared equals c squared. So we have 8 squared plus 10 squared equals c squared, which means that our hypotenuse here is going to be 12.8 meters per second. For the angle now, we're going to use our inverse trig, and I'm just going to jump right to this. Tangent of that angle is going to be equal to my opposite side, which in this case is this 8 meters per second, over my adjacent side of 10 meters. So the tangent of theta is going to be 8 over 10, which means that theta is the inverse tangent, remember second tangent, of 8 over 10. And so I find that my angle here is going to be 38.7 degrees, and that's going to be south of east based on how I have it drawn. The other acceptable answer would be the complementary angle there, which would be 51.3 degrees east of south. So either one of those works for your angle. Move on to my final one here, C. We have 3 meters per second west, so there's my 3 meters per second, followed by 4 meters per second south. I line those up tip to tail. There's my hypotenuse. To get that hypotenuse, I'm Pythagorizing this. A squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared, so c is going to be 5 meters per second. Okay, and then to get the angle, I'm going to say tangent of theta equals opposite, which is 4, because I'm solving for this angle here, over adjacent, which is 3. So that means my angle is the inverse tangent of 4/3. And so that angle ends up being 53 degrees, and that would be south of west. Also acceptable, that alternate answer would be that our angle is 37 degrees west of south. Either one works. So just a quick recap of that one little math thing that we did on the last problem, because maybe you might be a little rusty or unfamiliar with this, but if you're given the equation x squared equals 9 and you wanted to solve for x, what you would do is you would take the square root, because that square there is a function. It's not a number. We can't divide by it. We can't subtract it. We have to undo that function. And so the way we undo that is we take the square root. Okay, that's undoing that squared. Similarly, to get rid of sine or cosine or tangent, any of those trig functions, we use the inverse sine, the inverse cosine, or the inverse tangent. So if we have sine of theta is equal to 0.5, the way we undo that is we take the inverse sine of both sides. When we do the inverse sine of the sine, it basically cancels out, and we're left with theta is simply the inverse sine of 0.5. And the way we get it on a calculator is we just hit that second button at whatever function we want to take the inverse of, sine, cosine, or tangent. One last thing that I want to talk about here, and this is actually going to lead us into the next thing we talk about vectors a little bit later on, and that is the question of, we've done stuff with vectors, but I want to talk about the meaning behind it. So here's the question: why do we draw those vectors perpendicular? So here's what I want you to think about. If we have a person who walks due north, meaning straight in the north direction, how far, for 18 hours, how far did they walk east and how far did they walk west? Okay? And the answer obviously is they didn't. Okay? If you're walking directly in the north direction, it means that you are not walking east, nor are you walking west. Another one to think about is it possible to move a box to the right by pushing straight down on it? And you're certainly welcome to try and do this. But spoiler alert here, it can't be done. Okay, you can't move a box left or right by pushing down on it. And the reason for all of this is that x and y are independent of each other. The fancy mathematical term we use for this is orthogonal. So if you would like to impress people at parties, you can use that word. And what that simply means is that whatever happens in the x has nothing to do with the y. Whatever happens in the y has nothing to do with the x. Okay, the reason why we're constantly splitting vectors into x and y is because x and y are independent. X and y are orthogonal. All right, and we're going to take advantage of that, and we'll see in a little bit when we start getting into forces and actually applying this to some problems. But we're going to take advantage of that fact that the x and y are independent and split things into vectors to make our lives a lot easier.